is more beautiful than humanity's dreams.
And all these little dots are stars?
All these little dots are galaxies, some of which are bigger than our own.
Breaking news. We may have just found potential evidence of intelligent life beyond Earth.
This is a huge discovery, and we think that it's a huge discovery. And that's the most exciting piece of this telescope, of this remarkable instrument we put in space, is finding things that we didn't expect, that we can't explain, because that means that we have to revise our understanding of the universe.
Well, JWST is so phenomenal that if you spend enough time, you could probably find any galaxy that ever formed in the universe. It's really that powerful.
NASA's James Webb Space Telescope has scarcely woken up, and the universe is now more puzzling and more gorgeous than humankind's fantasies. All these tiny specks are stars, and all these countless little spots are galaxies, some of which are larger than our own. This is an enormous discovery, and we feel that it's a tremendous revelation. The most thrilling part of this striking instrument we've placed in space is discovering things we didn't expect and cannot explain. This means we must rethink our understanding of the universe. The JWST is extraordinary to the point that, if you invest enough time, you could probably find any galaxy that ever formed in the universe. It's truly that powerful. At long last, this evening marks the beginning of a new era in astronomy. NASA released a full set of images and data from the James Webb Space Telescope. This $10 billion telescope recently achieved a galactic milestone by capturing the most detailed image of Proxima b, an exoplanet located in the habitable zone of our nearest stellar neighbor, Proxima Centauri. What secrets lie in this distant world? Is it capable of supporting life? Let's examine what the James Webb Telescope just uncovered. Hello everyone. Welcome back to Imagine Space. Let's dive into the video. Launched on December 18, 2021, the James Webb Space Telescope is the most powerful and advanced space telescope ever built. A joint project by NASA, the European Space Agency (ESA), and the Canadian Space Agency (CSA. The James Webb Telescope is designed to explore the universe in infrared frequencies, providing unparalleled clarity and sensitivity. Equipped with a 6.5-meter primary mirror, the telescope is located at the second Lagrange point, L2, allowing it to observe the universe with minimal interference from Earth's atmosphere. Since life, as we know it, has the highest chance of emerging in habitable zones surrounding stars, it's no surprise that Proxima b, our closest known exoplanet, has captured astronomers' serious interest. Discovered in 2016, Proxima b orbits Proxima Centauri, a red dwarf star just over 4 light-years away from our solar system. What makes Proxima b so intriguing is its location within the habitable zone, where conditions might allow liquid water to exist, a key ingredient for life as we know it. The exoplanet's potential habitability has spurred immense interest among astronomers, making it an ideal target for the James Webb Space Telescope's observational capabilities. Proxima b, often referred to as Earth's cousin, is no ordinary rocky planet. It is a mystery and a wonder. Could it be another Earth, complete with oceans and diverse life? But Proxima Centauri b isn't alone in its journey around the red dwarf star. Proxima Centauri c, a super-Earth, is one of its companions. Who knows what else this stellar system might be hiding? Perhaps another undiscovered companion. Proxima b is strikingly similar in size to Earth, with a mass of 1.17 Earth masses. It orbits its star in just 11.2 days, compared to Earth's year-long orbit around the Sun. This means Proxima b is significantly closer to its star than Earth is to the Sun. However, because Proxima Centauri is a red dwarf, much smaller and cooler than our Sun, Proxima b's orbit is comfortably within its habitable zone. Remarkably, Proxima b receives about the same amount of solar energy from its star as Earth does from the Sun. Does this suggest there is water, or even life, on its surface? When we venture beyond our solar system, we discover a whole new universe of exoplanets. The star Proxima Centauri, which Proxima b orbits, is part of the Alpha Centauri triple star system, the closest star system to our own. This system is composed of Rigil Kentaurus, Alpha Centauri A, Ptolemy, Alpha Centauri b, and Proxima Centauri, Alpha Centauri c. Despite being the closest star to us, Proxima Centauri cannot be seen with the naked eye due to its apparent magnitude of 11.3. Red dwarf stars like Proxima Centauri are some of the most energy-efficient stars. Their internal convection processes keep them glowing for trillions of years, despite producing much less energy than larger stars like our Sun. Proxima Centauri, for example, will remain a main sequence star for an estimated 4 trillion years. However, there is ongoing debate about the habitability of red dwarf stars like Proxima Centauri. Their frequent and unpredictable flares, coupled with the proximity of their habitable zones, pose significant challenges to supporting life. Proxima b receives hundreds of times more intense ultraviolet radiation from its star than Earth does from the Sun. Although Proxima b's surface might resemble Earth's, scientists believe it lacks the right atmosphere to sustain life. Without a stable atmosphere to regulate climate and maintain a water-friendly surface, life as we know it would be impossible. Nonetheless, there is still hope among some scientists who are eager to uncover the truth about Proxima b. The James Webb Space Telescope's advanced instruments, including its near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, have captured unprecedented details of Proxima b's surface, atmosphere, and overall composition. This data will enhance our understanding of exoplanetary atmospheres and improve our ability to assess the habitability of distant worlds. In April 2021, a flare from Proxima Centauri was recorded that was 100 times more powerful than any solar flare ever observed. Such extreme radiation could make life on Proxima b incredibly challenging. Despite these obstacles, the idea of a habitable planet orbiting Proxima Centauri remains fascinating. Humankind has long been captivated by the possibility of contacting extraterrestrial life. In late 2020, a peculiar signal was detected from the Alpha Centauri system with an unusual frequency of 982.551 MHz, sparking renewed excitement about the potential for discovering alien life. Reaching Alpha Centauri, however, remains a daunting challenge. Current technology would take 6,000 years to travel there. Innovative projects like Breakthrough Starshot aim to reduce travel times by using powerful lasers to propel spacecraft toward Alpha Centauri. While promising, these efforts face significant technical hurdles, including overcoming the distortion of lasers by Earth's atmosphere and generating the immense power needed to achieve such a feat. Fit for molding their current circumstances, perhaps making city-like structures, this is the sort of discovery that causes you to sit up and acknowledge just how vast the universe truly is. But as exciting as this all sounds, it leaves us with so many questions. If these lights are from a civilization, just how advanced are they? Are we talking about a society like our own, one that is experiencing its own technological developments and struggles, or is this something considerably more evolved? These lights cover a significant portion of the planet, according to data from the James Webb Telescope. That could mean either one massive city or a collection of smaller settlements scattered across the planet. Either way, we are talking about an organized society, not just random lights here and there. And then, of course, there's another question. How are these lights powered? Are they using something like electricity as we do, generated from natural resources such as coal, solar, or wind? Or have they developed some advanced form of energy that we cannot yet imagine? Proxima b orbits a red dwarf star, which is much cooler and dimmer than our Sun. This could mean the inhabitants had to get creative with their energy production, perhaps harnessing energy in ways that could give us clues about solving our own energy problems on Earth. But what if these lights are just the remnants of a civilization? Think about it. What if this is a society that once thrived but is now in decline? What might have caused it? Perhaps they faced internal conflict, ran into environmental problems, or experienced some vast cosmic disaster. On the other hand, what if the civilization is still flourishing? If that's the case, it raises the possibility of genuine contact between us and them. And then we must consider whether we should even attempt to make contact. History shows us that when two civilizations meet, things don't always go smoothly. We have countless examples from our own history where encounters between human societies led to either cooperation or conflict. So, if we do decide to reach out to this alien civilization, what might that look like? Do we approach them cautiously, or do we dive straight in? The ethical and practical questions are endless, and frankly a bit frightening. There's also the larger challenge to our understanding of where life can exist. For the longest time, scientists believed that planets orbiting red dwarf stars were not exactly life-friendly. These stars often release powerful solar flares, which could easily strip away an atmosphere and leave a planet desolate. Yet here we are with potential evidence of not just life but intelligent life flourishing under such conditions. If that's the case, it would completely change our understanding of where life could exist in the universe. Red dwarfs are the most common type of star in our galaxy. If life can thrive on Proxima b, that means there could be many other planets around red dwarfs where life could also exist. Suddenly, the universe looks much more crowded. Even the places we once thought were unlikely candidates for life might require a second look. Space exploration, a game changer. This discovery could be a game changer for space exploration. The fact that Proxima b is relatively close to Earth in galactic terms makes it a practical target for future missions. It is 4.24 light-years away. Sure, that distance is still vast by human standards, but in the grand scheme of the universe, it's practically in our backyard. Over the years, there's been increasing talk about sending probes or even crewed missions to nearby star systems. Now, with the possibility of city lights on Proxima b, things could accelerate significantly. Scientists could develop advanced propulsion technologies so we can study Proxima b and its potential inhabitants up close. The idea is no longer as far-fetched as it once seemed. The discovery of potential artificial lights there makes it an even more exciting candidate for future exploration. The goal is to gather more data, get closer to the planet, and perhaps determine if we are truly dealing with an intelligent civilization. New methods in the search for life. This isn't the first time we've tried to find extraterrestrial life. We already have an organization called SETI, Search for Extraterrestrial Intelligence, which has traditionally focused on trying to detect radio signals or other forms of communication from distant civilizations. But with this new discovery, we may need to change our approach. Finding city lights instead of listening for signals suggests we should look for other signs of advanced technology. Imagine if there are more planets like Proxima b, where artificial lighting or even massive structures could indicate life. This could mark the beginning of a whole new era in the search for extraterrestrial intelligence. And it's not just scientists who are excited. This discovery has captured the public's imagination like few other space-related events in recent years. The idea that an alien civilization might be close enough for us to see the lights of its cities is both thrilling and inspiring. People are following every update from the James Webb telescope and eagerly awaiting what comes next. And honestly, who could blame them?